Hello and welcome to another Solana tutorial. Today we're going to talk about return values, since programs don't only succeed or fail. If they succeed, you can return a value. And I think I never really did a deep dive on how that works. We had a look at it a few times, but I don't have sufficient enough understanding of it yet that I'm happy with that. So today we're gonna have a closer look at return values and specifically how we implement this in Pinocchio. I think this is just not talked about a lot because it's not used a lot. This functionality exists. It's just in most of the cases, like in 99% of the cases, if you call an instruction, it's sufficient to know if it succeeded, because then it did the thing that it's supposed to do, and otherwise it will return an error, and the transaction will fail anyway. But there are a few cases where a return value makes sense. The most prominent place where we see that is at the token program for getting account size. With token extensions, there's different account sizes depending on which extensions you use. And the Token 2022 program has an instruction that tells you what size you need, because the account needs to be created outside of the program, and then the program just initializes the account. That's why there is an instruction that returns a number, the size of the account. We also saw implementations when we were converting UI amount to actual token amount. That was also at the token extensions program, by the way. For the interest bearing mint, there is an instruction that allows you to convert between the actual amount and the UI amount. But that one mainly exists that you can simulate it and then show the results on your user interface. It's not that other programs would call it and then use that value. So maybe working with return values is just not something that we need a lot on Solana, but yet I do want to understand it better, and I do want to know how I can do that with Pinocchio, because I didn't manage. When I did the Getting Started video series last month, I realized, hey, wait, I don't know how I can return that value here, so I just skipped it, and I was like, it's fine if we just print it. Let me show you. When I was doing the get mood, I wanted to return this data, but I didn't manage because this program result has the unit type here, and I can't give it a return value. So today, I want to figure out how I can return something in a native Rust Solana program or with Pinocchio, because I think they're using the same type. So let's get started. Let's make a return program, cargo init and cargo add Pinocchio. Okay, we will add our classic lib type to the cargo toml, and we'll just go with this standard Pinocchio. Oh yeah, if I need, I will allow myself to use Solana program log. And this program will have one instruction, and I'm calling it the get answer instruction. That's gonna be directly my entry point. And what it's supposed to do is it will return the answer. So somehow I need to be able to get the answer in here. But how do I do this? How can I use a different program result? Where does that come from? That comes from Solana program error, and it's a core result with this and program error, and that's the program errors as we know them. So this deals with errors, but I can't have a program result. I need a program result with return value. That would be, I don't know, a U8 is enough for me. If I just want to return 1 byte and then the program error. And now my question is, if I use this thing here, will the entry point complain? Yes, the entry point will complain, because obviously the entry point expects something that returns a program result and not a program result with a return value. But if we look at that, the entry point does return a U64. Yeah, the 0 represents success and everything else represents an error. So how can I even do a return value then? I know how it's done in Anchor. I mean, in Anchor it was super simple. I just say the result has this type and then I can return that. But what's happening behind the scenes here that I can do that? I didn't even really know what it means to have a return value, because If you look at it the C way, then it's just a function that returns a value, and anything that's non-zero is an error. And so how do we have a return value? By writing something to register 1 or whatever. That's how I would do it in assembly. Yeah, but then how does it work for Solana programs? Good that we're doing a deep dive on that, because I have no idea. Like no idea how return values work. We call the process instruction with that stuff. And on OK we have success, and on error we error into, and success is 0, and that's what we return. So that's how we get from the entry point to a U64. So there is no way to return anything here, because I just get success will just allow me to return 0 here. So how can I do a return value? Well, if you have no idea how something works, but you've seen it somewhere, it's a good idea to just have a look at the source code of where you've seen it work. Solana programs, SPL token. Oh wait, no. We want token 2022. And where did we see this? Not in the interface, in the implementation. Processor, there we go. Process get account data size. Here we are. Look, it's an OK as well. It also says OK, but look at what's here. Set return data. We found it. My precious. Set return data. Where does that come from? From Solana CPI. Good. So it is probably something like we are writing it somewhere specific. Okay. So that means I don't need to mess with this program result. That can stay the same. And I will return unit. But I will set return, and I don't have that because I don't have Solana CPI. If I add the Solana CPI package, then I can set return data, which comes from Solana CPI. And the data can be any slice of bytes, so I can return whatever I want here. I just need to serialize it the way I want it. And if you don't know about serialization, I made a video about that in my Getting Started series. The very one where I had the problem of not knowing how to do return data. Return data is a dedicated per transaction buffer for data passed from cross-program invoked programs back to their caller. Right. So if we do a CPI, that's why we're in this package, Solana CPI. So there's a per transaction. So one transaction will have one buffer is what that means. And yeah, it's enough to have one because we always just return one level. So if I do a CPI and I have a return value, then one buffer is enough. And if I then return something again, I can use the same buffer to return something. So yes, cool. The maximum size of return data is max return data. Return data is retrieved by caller with get return data. Oh, great. Now we also know how we can get return data. Ah, isn't that easy? If you find it, yes. Nice. Okay. So here I would just, can I do that, or does that not live long enough? I think I can do that. I just return 1 byte. I could return max return data, which is 1024 bytes. I could return up to 1 kilobyte of data. And maybe we will do that. But for now, let's stay with 1 byte. So all my program does is return 42, the answer. Hey, that's simple. But if you don't know how it's done, then it might look difficult. Let's see. Can we build SPF? Here we go. We're building. I don't like this key. I'm gonna create myself one that starts with 42. Program DJ. Yeah. And then I copy the 42 program DJ to the program target deploy thingy pair. Then I still have some sol. Great. And with that I can Solana program deploy the target deploy program, deploying this to DevNet in 6 transactions. Isn't that nice? Great. So this program is now on chain, and we will use skill. And to call our program, we literally just need to put in the program address, which is this one, the 42 program DJ. No data, no accounts. And I just npx tsx call the program, which gives me this transaction. And it didn't do anything really, but we do have a program return. That program returned that value, and that's base 64. And if we decode that, we would get the answer. and I will just trust that if we decode it is actually 42, I'm not even gonna test that. Because I, as the user, am not particularly interested in this return value. Though if I was, let's also do that since we're talking about return values. So after it's confirmed, I could be like, get the transaction for the signature. It's also the same that is this one, but I'm just gonna have that. And then, oh wait, I need to send this. Let's print the entire thing. And in this thing, status is okay. And the return data is in the meta. Okay, so in meta, we have return data. And this thing is return data. I guess that's the, let's just look at it. Yep, there we go. We have the data itself, which is the base 64 encoded thing, and which program returned this. Because there's one buffer and maybe the buffer is not cleared every time. So to make sure that it's that program that we actually called and not an inner program, the program ID is also written there, probably. That's why we see it here as well. When program return, we write which program did the return and then this. And also, we did a video once on a program can't be called again once it was already called before, unless it's calling itself. So there is no recursive CPI. Made a video on that once. That's why that is safe. But anyway, if we then want to actually get the value of it, I can... So actually that's not the return value, that's return data. And the return value is, I need a base 64 codec and encode, which is the actual decode of the return data dot data 0. And then I can also print this, and that should then in fact be my 42. Boom, we have 1 byte 42. Wonderful. Okay, we still get the entire uint8 array back that can be up to 1 kilobyte in size, but really we're just using 1 byte, so I could also do this and then I really just have the 42. But yeah, you get that. That's how we get it from the actual transaction. We can do that before, even before we send the transaction. Maybe we don't even want to send the transaction, but we just want to have the program result anyway. We want the answer without having to send the transaction. We can of course do that by simply simulating it. So before we send, we could await an RPC simulate transaction, and we simulate this signed transaction like this. Look, that's how we gotta do it. We gotta say we want base 64 encoding and then give it a base 64 encoded wire transaction. Then we can simulate it, and from the simulation, oh wait, we also need to send this. Send it. And then from that, it gives us the context and the value will have return data. And that return data, once again, has program ID and data, and that is then the same as we had here. So I could put that here, and the rest would be the same, and then I wouldn't even need to send that transaction. I could just simulate it. There you go. Now we would simulate this. This transaction was never sent. I just got the signature, but it's never sent. And I do get the same return value. So I can just simulate this transaction that contains this instruction to my program and get the return value from the simulation, which in some use cases is what you want to do. Some programs have instructions that are just supposed to be simulated for you to get the result and then used that some other way. It's not intended to actually be used within a program in a CPI. So that's one use case for return values. The other use case though is if we have another program calling my program that will then actually use the return value as well. So let's do that. Let's have a new program, calling program, and also here a cargo init a lib. And I will copy that into the cargo and cargo add Pinocchio again. And we will also probably need the Solana CLI stuff. There we go. And when we process this instruction, we're gonna expect one account, and that is the program that we're gonna call, that we're gonna CPI into. So we're not gonna return something, but we're gonna CPI into the program that returns us something. So step one, do a CPI. How did that work? With invoke, do we not have Solana CPI? I thought we had that. Oh no, we didn't. Oh, I typed CLI. Whoops! No, we don't need the CLI, we need CPI. Hey, okay. that explains stuff. But now we should have, yeah, there we go. We have invoke and invoke signed. We don't need to invoke signed. We don't need to sign for any PDA. So that needs an instruction and gives again result with OK or program error. So we don't get the return value from this. I'm just gonna build myself an instruction because it's quick. Program ID, that will be the account's first one, or should we do program to call is this one as reference, and then we do program to call address. Accounts, it doesn't need any. Data, it doesn't need any. And then the account in, wait, still not happy with that. How do I get an instruction? Where does it live? Well, I guess we gotta cargo add Solana instruction then. Ah, there we go. No, wait, now we can import this, and there we go. And accounts, you expect a vector. Well, that's a bit inefficient, but have an empty vector, you too. There you go. How do I get the account info from that thing again? I know that in direct Rust I could just parse in the entire accounts thing, but here it's just a view. And I've heard that they want to get rid of those account infos anyway, but for now, oh well. Well, then what do you need? You need a slice of account info. This will not work because you don't have the account info for that program that you call. But how do I get the account infos in Pinocchio? Well, let's first see what happens if I would do this. Let's also get a nice key for this. Call program through CPI. CPI JIT, that's the JIT. Okay, copy that to the calling program target deploy. Something key pair, and then over there we Solana deploy the target, deploy something program, Solana program deploy, of course, and then we can put that program here. Now we call our program the calling program and then the return program, and we put a return program address with role read only, since it's a program, as one of the accounts. And then let's see what would happen if we call that. That would actually work already. But look at this. Wait, let's look at it in Explorer, because that's fun. So our calling program that does the CPI into the program that returns 42. I don't like that it's loading instruction data so long. Why is that taking so long? It did one CPI, this program returned that, and then my program also returned the same thing. So the return buffer is never cleared. So two things here. Number one, my assumption that through this program ID we can check which program actually did the return is wrong, because even though that program didn't set that return value, it was just handed over to the next one. It's not actually being saved maybe, because we certainly did not return this, but it wasn't a return buffer, so therefore we did return it. That's the one thing. The other thing, if we do not do anything with the return data, it looks like we also return that thing, which kinda makes sense, because if returning something just means there is something in the return buffer and we're not clearing the return buffer, then yeah. But you need to be careful then that that actually comes from that program that you expect. Good that we're doing a deep dive on that. There's so many things that we can have a look at. But also we can note that for this account, apparently we didn't need the account info. If I don't provide account info, then it can also do the CPI. So okay, great, let's not worry about that account info. Don't ask me why I don't need that account info, but I don't seem to need that account info. Great. It seemed to manage to do that CPI just fine. Perfect. Let's not bother about this. And maybe that's already new, because they said they want to get rid of those account infos. Maybe that's already on DevNet, that's already a new feature. Who knows? Anyway, it does work, so I'm not going to bother about it. But I do want to get the return value out here, because I wanted to use it in my program. So what do I need to do? I need to say get return data, which also lives in the Solana CPI, and it gives me an option for, and here it gives me the pub key and the vector. Look, get the return data from an invoked program. For every transaction, there is a single buffer with maximum length, we've already read that, paired with a pub key representing the program ID of the program that most recently set the return data. Thus, the return data is a global resource and care must be taken to ensure that it represents what is expected. Called programs are free to set or not set their return data, and the return data may represent values set by programs multiple calls down the call stack, depending on the circumstances of transaction execution. Return data is set by the callee with set return data. Okay. Return data is cleared before every CPI invocation. If no return data was set by the previous CPI invocation, then this function returns none. Return data is not cleared after returning from CPI invocations. A program that has called another program may retrieve return data that was not set by the called program, but instead set by a program further down the call stack. Yeah, that's what we saw. Or if a program calls itself recursively, it's possible that the return data was not set by the immediate call to that program, but okay, yeah, that's for recursive calls, which we can only do from the same program. Likewise, an external RPC caller may see return data that was not set by the program it was directly calling, but a program that program called. And that thing with the RPC is what we're seeing here, or really here, when we are looking at the return data here. Because our CPI JIT program also gives the same return data. Although here, the program ID is set to 42 PR. So it does seem like it saves that. That's cool. Because that return data comes from this program, which is correct. It's not from this program that returns success, even though here it also says program return this, but that might just be the log that this program basically continues to return the same value, but really it comes from the inner invocation here. That's the actual program that said it. And when we look at the return data, it contains the program ID, and that actually contains the correct program ID of the one it actually set. Not this one. This line here made me believe that the return data is overwritten and now this program returned that thing, and that's what we would get back as return data. But no, we do get the actual program that set that. Okay, cool. That sounds good. Sounds good to me. So yeah, where were we? With the get return data, we get an option, which is great, with the pub key and the data. So we get the return data, and if we have some return data, then we can get the return value from the return data, unwrap, get the vector and the first byte. That looks fun, but that's how you write it. So we're getting the vector here and then the first byte of that vector, and then we can say log the answer is return value. That's not the right thing, or you just log strings. Yeah, I'm just gonna do it a bit complicated then. Okay, I'll just manually quickly do this, because why not? Just so I don't need to import the message crate. Yeah, and then I build this again, I deploy this again, and then I will call this again, and again we get the same return data, and it logs the answer is 42. So also getting the return data does not clear the return data buffer. It still stays there. This program still returns it. If I wanted to clear it, I set return data to an empty slice. Do I then return an empty slice, or do I then return nothing? That's another thing that we're gonna try out now. What if I build this, deploy this, and call this? We don't return anything anymore, I think. Here, this program returns something. Here we log this, and then we don't return anything anymore. So return data is null. So if I set it to an empty slice, then I don't return anything. So it's as if I don't have any return data. So basically, I can't return empty. I would need to return 1 byte with 0, whatever, to have return data. Or, you know, not having return data could mean that I return empty. Kind of the same thing. The point I was trying to make is an empty slice is something different than nothing, null. But I can't return an empty slice because that is as if I return nothing, which makes it nice as well, because then I just set that and it doesn't return anything, because otherwise I would say clear buffer and whatever, right? I would need another function, which I don't have, and that's good. So that allows me to clear the return data. Perfect. You also want to see that here. I don't know why it keeps loading instruction data. This is Explorer being buggy. I don't like how that looks. So yeah, this time just the 42 program returns something. Then my program reads the return data, says the answer is 42, and then it returns itself without return data anymore. So that's cool. Also, what we have learned from reading docs, but let's quickly test this. When we do a CPI, the return data is also cleared. So instead of this, let's say I add a second program. If account's length is less than 2, I just return OK without any return data or without anything. I want to do a recursive self CPI by putting my calling program here. If I don't have any accounts, then all it does is it returns. And that's what's going to happen here. I'm going to basically do the same as here. Program to call it the second program to call is this one, which is going to be my own program, but I don't necessarily know that here. I'll just again call that without any accounts, without any data. And that is basically just to prove that then the return data is overwritten. So if we build and deploy that, and then we call the program like that with itself as the second account, then we will see, so first it is invoked, it does the CPI to the 42 program, which gives me the answer, and then it invokes itself, returning success, and then we return success. But again, we have no return data, even though we did not clear the return data with set return data, but we did another CPI, and that automatically sets the return data to empty. Cool. We also checked that. Perfect. The docs are right. That's great. What else do we want to test? I mean, we know how return data works now. I feel like I learned a lot today. I love it. It's so simple, but you just got to know how it works. And then obviously you can return anything. You can return a string. You can return a whole object of stuff. You just need to serialize it into bytes and then deserialize it again. But yeah, that's so obvious that I don't even want to demonstrate that. However, what I do want to do now is checking for that address. So let's change this a little bit and first do the invocation of the program ourselves. So basically what I'm gonna do, if I have no accounts, I say okay, and otherwise I always take the program to call my first account, but I will put in the remaining accounts as arguments. How about that? So in this case, how do I get from an account view to an account meta again? Account meta, you need the pub key and the is signer, and this, okay, there you go. So what is happening now is we are going to put in first ourselves as a program to CPI into, and then the return program that returns an actual value, just to check if that works. And how that's supposed to go is in the first invocation of that program will invoke itself, and then inside it will invoke the other program, and then it will return and say the answer is this, and then yeah, let's just see what happens. Let's just build this, deploy this, and run this. I would assume that now I still get the return value 42, and I will get it twice, because I never clear it, and then I will also get it outside here at the RPC. Let's see. Yes, look, the return data 42 comes from here, from that program. And if we look at the logs, and that's quite a bit, but here, look at that. So we have the three levels. The CPI chit calls the CPI chit, calls the 42 program, which returns that. Answer is 42, so also that keeps returning, keeping the answer to 42 because I never cleared it, and then that keeps returning and the answer is still 42. If I were to clear it like I did here, then it would only be inside, so let's also quickly test that, deploy that, and if we run that, then now only the 42 program returns something, so the inner execution finds this answer, but then clears the return value, so there's no return value for the next program. And because I said if there's no return value, then just ignore it, we're not printing this message and we don't have any return value. So also here we don't have any return value. That's what we expected. Cool. And now for the thing that I actually wanted to test, let's not clear it so it keeps being returned. But if we have return data, I want to check where it comes from. So something like log the answer was provided divided by, and then we log the return data. I'm gonna call this maybe return data, and then I'm gonna call this return data, this thing. There you go. And then from this return data, this will have the 0, which is an address. That's where it comes from. That's who returned it. And to log this, I will do a toString, which is not efficient, but I don't care about that here. Build this, deploy this, run this, and let's see where it comes from. Nice. So here in the inner one, the answer is 42, and the answer was provided by the 42 program. And also outside, even though the CPI JIT returns that, or the program log says that, the answer is still 42, and the answer was again provided by the 42 program, not the CPI JIT. Great. So that's cool. So it does store which program actually returned it, and we can access it in the return data 0, so in the address that we're getting back. To not use 0 and 1, I could write that nicer by doing, I could do something like that. The address of the program returning would then be this, and the return data would then be the vector directly. This maybe reads a bit better now, so I don't need to say .1 and .0. But yeah, I think you get it, and that's pretty cool. Okay, I'm almost done, but I want to do a few more things. What happens if I return more than 1 byte? So for instance, I want to return a string. Let my return message be this entire string is being returned as return data of program, and then I use this program ID here, program ID toString, push that on that string, and that entire string that I built here I want to return. So I set return data and I use the return message as bytes, which will make it a uint8 slice. That's exactly what I need. Perfect. So let's build and deploy that. And then we call it, look, now the return data looks bigger. This is just a base64 encoded uint8 array. The answer is 84 now because I'm just reading the first byte. But we see it's setting the return data, and the answer was provided by this program as before. I gotta change that program as well. We've seen that. I'm not gonna log that anymore. And here, instead of this one return value, instead of this 1 byte, I'm gonna say, so now I need to, from this data, get a string again. How do I do that? From UTF-8, and I put the return data vector. So that was the actual data vector. That's the U8 vector that we got from the return data here. I make a string from that, and then I log this. Oh, this is still the result. Unwrap. Not super clean, but again, I don't really mind. I know that this is a string. I should probably do some more checking, but I don't want to. So if I build and deploy this, and then I call it again, get the same return value. But now my program logs this entire string is being returned as return data of program 42PR something something. Nice. So that's already outside in the CPI JIT program. Nice! And also here, same string because it keeps returning it. And if I wouldn't want it to keep returning it, I could set it to empty. And then only the inner invocation gets to see this return value and the outer one doesn't. And then also here I don't get any return value. Yeah, cool, that's return values. And here in this example we put in a string, but you can put in arbitrary things. Oh, one very last thing now before I go. What happens if I put in something that is more than 1 kilobyte? Let's also see that. What happens if I want to set something as return data? Let's do this and we make a slice of it. Nice. So that's 1 byte too much. Let's see what happens. Let's see what happens if I build and deploy this. And then we call this. Then our simulation fails already. Program failed to complete. Return data too large. There is a return data too large error. And it's a program failed to complete instruction error. Instruction 0, program failed to complete. That's the program error. And the reason is return data too large. The error of this, so if I just call the return program, so I'm just calling this program now directly, then I get failed with return data too large. The simulation I get error, instruction error. It's also here, it's a program failed to complete, instruction 0, and we fail with return data too large. However, if it was only 1 byte fewer, then it should work. Wait, I need to deploy. Then this should work again. Oh, wait, interesting. Hold on, I'm logging the error. Do I return anything? Yeah, I return a lot of zeros. Whee! A lot of A's. Whee! Lots of zeros that I return. Great. And then also the other one, that's what it returns. And then I overwrite it. But if I wouldn't overwrite it, I would keep returning it all the way out. And then I also get it as return data here. A lot of A's. A lot of A's. So this one returns it, then this one returns it, and then this one returns it. A kilobyte of zeros, which you can totally do. You can also return a kilobyte of 255s. No one's stopping you from doing that. Then this will look different. Then it looks like this. Look, that's what we return now. Base 64 encoded. Win. That's what we get as return data. A lot of 255s. Yeah. Cool. That's return data for you. We learned how we can set it in our Rust program. What's actually happening here, there is a separate buffer that every transaction has where it writes that data to. So it's a separate thing. It's not a direct return value of the function because the function returns the error code or 0 on success. But to use return data, we get a separate 1 kilobyte buffer. That's cool. I say we learned something today. I'm happy with that. I'm gonna end here, because for sure I could play around with that for several more hours, but we don't want this video to get forever long, so we shall end it here. Nice! Return values, isn't that fun? As I said, we're not using that a lot. You can probably find ways around it as well, but for some occasions, it is very nice to be able to return something from a program to the calling program. Something bigger, something that is not just success. Obviously, you can write into accounts and then read from those accounts again, but there is this return data buffer that we have access to for stuff like, let me know what account size you need. Or maybe you build an instruction that allows you to build the correct instruction data for another instruction, something like that. And even just for knowing that this thing exists, I think it was good that I made this video. Even if you don't use it yourself, other programs are using it and you want to understand that that's a thing, because that helps you grasp what the associated token program is doing with the token program when it gets the account size. That's just working with return data. So yeah, when we now read program code that says set return data or get return data, then we know what's happening here. And that's cool. Alright, if you also think that's cool, give me a like, subscribe if you haven't already. Here's some more videos that you can watch, and then I will see you in the next one, where we deep dive on some other Solana topic. Till then, bye bye. I'm gonna return myself to the outside, because that's calling for me.